Neuroscience has also produced results that are equally hostile to the traditional idea of souls, and therefore to any approach to spirituality that presupposes their existence. One such finding, conclusively demonstrated in humans and animals since the 1950s, is widely known as the split brain, a phenomenon so at odds with common sense that even within the culture of science, it has defied integration into our thoughts. The human brain is divided at the level of the cerebrum, everything above the brainstem, into right and left hemispheres. The reason for this is still unclear, but it does not seem altogether strange that the left-right symmetry of our bodies would be reflected in our central nervous system. This structure turns out to have surprising consequences. The right and left hemispheres of all vertebrate brains are connected by several nerve tracts called commissures, the function of which we now know is to pass information back and forth between them. The main commissure in the brains of placental mammals like ourselves is the corpus callosum, the fibers of which link similar regions of the cortex across the hemispheres. The evolutionary history of this structure is still a matter of dispute, but in human beings it represents a larger system of connectivity than the sum of all the fibers linking the cortex to the rest of the nervous system. As we are about to see, the unity of every human mind depends on the normal functioning of these connections. Without them, our brains and minds are divided. Certain people have had their forebrain commissures surgically severed. This is generally undertaken as a treatment for severe epilepsy, though other surgeries occasionally require that some of these fibers be cut. As a treatment for epilepsy, patients usually receive a collosotomy, a procedure whereby most or all of the corpus callosum is severed to prevent local storms of unregulated activity from spreading throughout the brain and producing a seizure. The split brain was brought to the world's attention half a century ago by Roger W. Sperry and colleagues. Sperry was awarded a Nobel Prize in 1981 for this work, which inspired a literature that now spans neuroscience, psychology, linguistics, psychiatry, and philosophy. Before Sperry began his research, it appeared that dividing the brains of these patients simply mitigated their seizures, which was, after all, the point, without producing any changes in their behavior. This seemed to lend credence to the ancient notion that the corpus callosum does nothing more than hold the two hemispheres of the brain together. Once patients recover from this surgery, they generally appear quite normal, even on neurological exam. Under the experimental conditions that Sperry and his colleagues devised, however, first in cats and monkeys and then in humans, two principal findings emerged. First, the left and right hemispheres of the brain display a high degree of functional specialization. This discovery was not entirely new because it had been known for at least a century that damage to the left hemisphere could impair the use of language. But the split brain procedure allowed scientists to test each hemisphere independently on a variety of tasks, revealing a range of segregated abilities. The second finding was that when the forebrain commissures are cut, the hemispheres display an altogether astonishing functional independence, including separate memories, learning processes, behavioral intentions, and, it seems all but certain, centers of conscious experience. The independence of the hemispheres in a split-brain patient comes about because most nerve tracts running to and from the cortex are segregated, left and right. Everything that falls in the left visual field of each eye, for instance, is projected to the right hemisphere of the brain, and everything in the right visual field is projected to the left hemisphere. The same pattern holds for both sensation and fine motor control in our extremities. Thus, each hemisphere relies on intact commissures to receive information from its own side of the world. While it can rarely speak, because speech is usually confined to the left hemisphere, the right hemisphere can respond to questions by pointing to written words and objects with the left hand. The classic demonstration of hemispheric independence in a split-brain patient runs as follows. Show the right hemisphere a word, egg, say, by briefly flashing it in the left half of the visual field, and the subject, speaking from his language-dominant left hemisphere, will claim to have seen nothing at all. Ask him to reach behind a partition and select with his left hand, which is predominantly controlled by the right hemisphere, the thing that he, quote, did not see, and he will succeed in picking out an egg from among a multitude of objects. Ask him to name the item he now holds in his left hand, without allowing the left hemisphere to get a look at it, and he will be unable to reply. If shown the egg and asked why he selected it from among the available materials, he will probably confabulate an answer, again with his language-dominant left hemisphere, saying something like, "Oh, I picked it because I had eggs for breakfast yesterday." This is a peculiar state of affairs. When the lateralization of inputs to the brain is exploited in this way, it becomes difficult to say that the person whose brain has been split is a single subject, for everything about his behavior suggests that a silent intelligence lurks in his right hemisphere, about which the articulate left hemisphere knows nothing. The duality of mind is further demonstrated by the fact that these patients can simultaneously perform separate manual tasks. For instance, a person whose brain is functioning normally will find it impossible to draw incompatible figures simultaneously with right and left hands. Divided brains accomplish this task easily, like two artists working in parallel. In the acute phase after surgery, patients' left and right hands sometimes engage in a tug-of-war over an object or sabotage each other's work. The left hemisphere can speak about its condition and may even understand the anatomical details of the procedure that has brought it about, yet it remains remarkably naive about the experience of its neighbor on the right. Even many years after surgery, the left hemispheres of these subjects express surprise and irritation when their right hemispheres respond to an experimenter's instructions. To ask the left hemisphere what it is like not to know what the right hemisphere is thinking is rather like asking a normal subject what it is like not to know what another person is thinking. He simply does not know what the other person is thinking, or even perhaps that he or she exists. What is most startling about the split brain phenomenon is that we have every reason to believe that the isolated right hemisphere is independently conscious. It is true that some scientists and philosophers have resisted this conclusion, but none have done so credibly. If complex language were necessary for consciousness, then all non-human animals and human infants would be devoid of consciousness in principle. If those whose left hemispheres have been surgically removed are still believed to be conscious, and they are, how could the mere presence of a functioning left hemisphere rob the right one of its subjectivity in the case of a split brain patient? The consciousness of the right hemisphere is especially difficult to deny whenever a subject possesses linguistic ability on both sides of the brain, because in such cases the divided hemispheres often express different intentions. In a famous example, a young patient was asked what he wanted to be when he grew up. His left brain replied, a draftsman, while his right brain used letter cards to spell out racing driver. In fact, the divided hemispheres sometimes seem to address each other directly, in the form of a verbalized interhemispheric argument. In such cases, each hemisphere might well have its own beliefs. Consider what this says about the dogma widely held under Christianity and Islam, that a person's salvation depends upon her believing the right doctrine about God. If a split-brain patient's left hemisphere accepts the divinity of Jesus, but the right doesn't, are we to imagine that she now harbors two immortal souls, one destined for the company of angels and the other for an eternity in hellfire? The question of whether there is something that it is like to be the right hemisphere of a split-brain patient must be answered in the only way that it is ever answered in science. We can merely observe that its behavior and underlying neurology are sufficiently similar to that which we know to be correlated with consciousness in our own case. There is no difficulty in doing this for a normal split-brain patient who retains the use of her left hand. In fact, the consciousness of the disconnected right hemisphere is easier to establish than that for most toddlers. The question of whether the right hemisphere is conscious is really a pseudo-mystery used to bar the door to a great one, the uncanny fact that the human mind can be divided with a knife. Structure and function. The right and left hemispheres of our brain show differences in their gross anatomy, many of which are also found in the brains of other animals. In humans, the left hemisphere generally makes a unique contribution to language and to the performance of complex movements. Consequently, damage on this side tends to be accompanied by aphasia, impairment of spoken or written language, and apraxia, impairment of coordinated movement. People usually show a right ear, left hemisphere, advantage for words, digits, nonsense syllables, Morse code, difficult rhythms, and the ordering of temporal information, whereas they show a left ear, right hemisphere, advantage for melodies, musical chords, environmental sounds, and tones of voice. Similar differences have been found for other senses as well. We know, for instance, that the right hand, sensation from which projects almost entirely to the left hemisphere, is better able to discriminate the order of stimuli, while the left hand is more sensitive to their spatial characteristics. However, the right hemisphere is dominant for many higher cognitive abilities, both in normal brains and in those that have been surgically divided. It tends to have an advantage when reading faces, intuiting geometrical principles and spatial relationships, perceiving wholes from a collection of parts, and judging musical chords. The right hemisphere is also better at displaying emotion with the left side of the face, and at detecting emotions in others. Interestingly, this obliges us to view one another's least expressive side of the face, the right, with our most emotionally astute hemisphere, the right, and vice versa. Psychopaths generally do not show this right hemisphere advantage for the perception of emotion. Perhaps this is one reason why they are bad at detecting emotional distress in others. Most evidence suggests that the two hemispheres differ in temperament, and it now seems uncontroversial to say that they can make different and even opposing contributions to a person's emotional life. In a divided brain, the hemispheres are unlikely to perceive self and world in the same way, nor are they likely to feel the same way about them. Much of what makes us human is generally accomplished by the right side of the brain. Consequently, we have every reason to believe that the disconnected right hemisphere is independently conscious, and that the divided brain harbors two distinct points of view. This fact poses an insurmountable problem for the notion that each of us has a single, indivisible self, much less an immortal soul. The idea of a soul arises from the feeling that our subjectivity has a unity, simplicity, and integrity that must somehow transcend the biochemical wheelworks of the body. But the split brain phenomenon proves that our subjectivity can quite literally be sliced in two. This is why Sir John Eccles, a neuroscientist and committed Christian, declared against all evidence that the right hemisphere of the divided brain must be unconscious. This fact also has interesting ethical repercussions. For instance, the biologist Lee Silver wonders what we should do if a person with a split brain wanted to have her right hemisphere removed because she could no longer endure the conflict with her other self. Would this be a therapeutic intervention or a murder? However, the most important implications are for our view of consciousness. It is divisible, and therefore more fundamental than any apparent self. Imagine undergoing a complete colostomy. Like most surgeries of this kind, you could be kept awake, because there are no pain receptors in the brain. There's also no reason to think that you would lose consciousness during the procedure, because a person can have an entire hemisphere removed, a hemispherectomy, without the loss of consciousness. Nor would you suffer any lapse in memory. After surgery, you would tend to speak in a way characteristic of alexithymia, the inability to describe your emotional life. And you might also demonstrate an inappropriate degree of politeness. Whether or not you had occasion to notice these changes in yourself, it seems all but certain that you would retain your sense of being a self throughout the experience. Given that each hemisphere in your divided brain would have its own point of view, whereas you now appear to have only one, it is natural to wonder which side of the longitudinal fissure you would find yourself on once the corpus callosum was cut. Would you land on the right or the left? It is hard to resist the uncanny demands of arithmetic here. Assuming that you were not simply extinguished and replaced by two new subjects, which seems ruled out by the fact that you would probably remain conscious throughout the procedure and retain your memories, it is tempting to conclude that your subjectivity must collapse to a single hemisphere. Once the surgery was over, it would be obvious that you can't be on both sides of the Great Divide. Perhaps it is reasonable to believe that you would find yourself in the left hemisphere, retaining the reins of speech, since speech and discursive thinking do much to define your experience in the present. But consider some of the other cognitive abilities you now consciously enjoy, which we know are governed primarily by your right hemisphere. Who, for instance, would greet your loved ones with your left hand and effortlessly recognize their faces, their facial expressions, and their tones of voice? I think this riddle admits of a rather straightforward solution. Consciousness, whatever its relation to neural events, is divisible. And just as it isn't shared between the brains of separate individuals, it need not be shared between the hemispheres of a single brain once the structures that facilitate such sharing have been cut. If some way of linking two brains with an artificial commissure were ever devised, we should expect that what had been two distinct persons would be unified in the only sense that consciousness is ever unified, as a single point of view, and unified in the only sense that minds are ever unified, by virtue of common contents and functional abilities. The experience of dreaming is instructive here. Each night we lie down to sleep, only to be stolen from our beds and plunged into a realm where our personal histories and the laws of nature no longer apply. Generally, we do not retain enough of a purchase on reality to even notice that anything out of the ordinary has happened. The most astonishing quality of dreams is surely our lack of astonishment when they arise. The sleeping brain seems to have no expectation of continuity from one moment to the next. This is probably owing to the diminished activity in the frontal lobes that occurs during REM sleep. Thus, sweeping changes in our experience do not in principle detract from the unity of consciousness. Left to its own devices, consciousness seems happy to just experience one thing after the next. If my brain harbors only one conscious point of view, if all that is remembered, intended, and perceived is known by a single subject, then I enjoy unity of mind. The evidence is overwhelming, however, that such unity, if it ever exists in a human being, depends upon some humble tracts of white matter crossing the midline of the brain. Are our minds already split? Roger Sperry and his colleagues demonstrated in the 1950s that the corpus callosum cannot facilitate a complete transfer of learning between the cerebral hemispheres. After cutting the optic chiasma in cats, thereby confining the inputs of each eye to a single hemisphere, they discovered that only simple learning acquired through one eye could transfer to the other side of the brain. Given the immense amount of information processing that takes place in each hemisphere, it seems certain that even a normal human brain will be functionally split to one or another degree. 200 million nerve fibers seem insufficient to integrate the simultaneous activity of 20 billion neurons in the cerebral cortex, each of which makes hundreds or thousands, sometimes tens of thousands, of connections to its neighbors. Given this partitioning of information, how can our brains not harbor multiple centers of consciousness even now? The philosopher Roland Puccetti once observed that the existence of separate spheres of consciousness in the normal brain would explain one of the most perplexing features of split brain research. Why is it that the right hemisphere is generally willing to bear silent witness to the errors and confabulations of the left? Could it be that the right hemisphere is used to it? An answer consistent with the hypothesis of mental duality in the normal human brain suggests itself. The non-speaking hemisphere has known the true state of affairs from a very tender age. It has known this because beginning at age 2 or 3, it heard speech emanating from the common body that, as language development on the left proceeded, became too complex grammatically and syntactically for it to believe it was generating. The same, of course, for what it observed the preferred hand writing down in school through the years. Post-surgically, little has changed for the mute hemisphere, other than the loss of sensory information about the ipsilateral half of bodily space. Being inured to this status of cerebral helot, it goes along. Thankless cooperation can become a way of life. Take a moment to absorb how bizarre this possibility is. The point of view from which you are consciously hearing these words may not be the only conscious point of view to be found in your brain. It is one thing to say that you are unaware of a vast amount of activity in your brain. It is quite another to say that some of this activity is aware of itself and is watching your every move. There must be a reason why the structural integrity of the corpus callosum creates a functional unity of mind, insofar as it does. And perhaps it is only the division of the corpus callosum that makes for separated regions of consciousness in the human brain. But whatever the final lesson of the split brain is, it thoroughly violates our common-sense intuitions about the nature of our subjectivity. A person's experience of the world, while apparently unified in a normal brain, can be physically divided. The problem this poses for the study of consciousness may be insurmountable. If I were to interrogate my brain with the help of a colleague, one who is willing to expose my cortex and begin probing with a microelectrode, neither of us would know what to make of a region that failed to influence the contents of, quote, my consciousness. The split brain phenomenon suggests that all that I would be able to say is whether I, as perhaps only one among many centers of consciousness to be found in my brain, felt anything when my friend applied the current. Feeling nothing, I wouldn't know whether the neurons in question constituted a region of consciousness in their own right, for the simple reason that I might be just like a split-brain patient given to wonder with his articulate left hemisphere whether or not his right hemisphere is conscious. It surely is, and yet no amount of experimental probing on his part will drive the relevant facts into view. As long as we must correlate changes in the brain, or any other physical system, with first-person reports, any physical systems that are functionally mute may nevertheless prove to be conscious, and our attempt to understand the causes of consciousness will fail to take them into account. All brains and persons may be split to one or another degree. Each of us may live, even now, in a fluid state of split and overlapping subjectivity. Whether or not this seems plausible to you may not be the point. Another part of your brain may see the matter differently.